Hey folks, in this video we're talking about nuclide symbols. There's some sweet symbols to represent elements. Let's talk about them. We're going to look at them. Let's talk about them. So in this video, I would like you to be able to label the components that are found inside of a nuclide symbol. I would like you to be able to draw a nuclide symbol if you're given an amount of protons, electrons, and neutrons. I would like you to be able to determine the number of protons, electrons, and neutrons that are found in a particular atom if you're shown a nuclide symbol. And I'd like to meet a fuzzy friend. So let's get a crack-a-lackin'. Well, nuclide symbols, what are those? Well, nuclide symbol gives the symbol, the atomic number, the mass number, and then sometimes also the charge of an atom. And they look something like this guy. So this dude here tells me, oh, this is the symbol, this is the atomic number, the mass number, and there's no charge present. We'll learn where to find those in the next few slides and how to interpret these. So there's four parts to that nuclide symbol that I just mentioned: the symbol, the atomic number, mass number, and sometimes charge. And so the first thing we want to concern ourselves with is that symbol. These are the letters that represent a particular element. For example, hydrogen is represented by the letter H capitalized. Iron is represented by a capital F, lowercase e. With these symbols, they're always going to have the first letter capitalized, and sometimes if there is a second letter, it will always be lowercase. So that's the first thing we need to know. And then the atomic number is important too. If we know the symbol, we know what element we're talking about, and then therefore we know the atomic number, because what element we have is determined by the number of protons in an element. And so sometimes people use the symbol capital Z to represent atomic number. We might use that. And so this is going to be found in our nuclide symbol at the bottom left of the symbol itself. So here we can see we'll put our symbol real nice and big, and then our atomic number will live as a subscript, below script, sub, on the left side. Nifty, nifty. Well, the next two parts are the mass number. And so mass number, if you recall, is the number of protons plus the number of neutrons. And so this is sometimes represented with a symbol A, though we don't come across that as often. Our mass number we're going to put at the top left of our nuclide symbol. It's going to live above our atomic number. And so if we have both the mass number and atomic number, we can determine how many protons and how many neutrons there are in our particular element or atom. The last dude that sometimes shows up is charge. Charge, if you recall, is the number of protons minus the number of electrons. And so if there's no charge, we're not going to show it at all because there's no charge. So why would we bother talking about charge? But if there is a charge on our atom or ion, then we're going to put that in the top right of the element symbol. And so we can see here all of these different parts labeled. We have our symbol itself, the atomic number, which these two dudes are very much tied together. The atomic number determines the symbol determines the atomic number. And then we have mass number and charge, which those are a little bit more flexible and dependent on the neutrons and electrons that we find. Neat. Well, let's go through drawing them. And we'll do 2 practice problems. For starters, let's say we've got an element that has 34 protons, 34 electrons, and 17 neutrons. Why don't you pause the video and try drawing a nuclide symbol for this element? Try it now. Go. Great. You tried it. Well, let's go through together. The first thing I want to figure out is what is the symbol or element that we're talking about? Well, if we have 34 protons, I know atomic number is 34, so I can go to 34 on my periodic table and say, oh, I know who that is. 34 is, as I just said, the same as our atomic number, so we know this is going to be 34. We're also going to want to figure out our mass number. Remember, mass number is protons plus neutrons. So 34 plus 17, I can do that math easy. And charge, that's going to be protons minus electrons. So we have pretty much everything we need for this. Starting off, I guess I'll say my atomic number is 34, and then I'll look for 34 on the periodic table, and that's selenium, Se. 34, I don't know where that D snuck in. Sneaky D. Anyway, the mass number is going to be 34 plus 17, protons plus our neutrons, and that gives us 51. And my charge is going to be protons minus electrons, 34 minus 34, that's going to be 0, saying I have neutral charge. Well, let's go to the next slide to draw this out. Remember, I said our selenium is our symbol, our atomic number is 34, our mass number is 51, and our charge is 0. So I can just put this down, a nice big selenium. Atomic number, always going below the mass number. The number up top should always either be the same or larger than the atomic number. The mass will always either be the same or larger than the atomic number. So that was super easy peasy. Oh, look at this cute guy. He's vaguely menacing with this stare and the mysterious fur. Anyway, yeah, cutie pie. So let's go and interpret this nuclide symbol. So based on this, dude, I want you to try and figure out what is the number of protons, electrons, and neutrons in this bad boy. Why don't you pause the video and give that a shot? Meow. Sweet, you paused the video and done tried that. We'll go through it together. If I want to determine my number of protons, all right, I can look at this and say, atomic number is 29. That's the same as my number of protons. Atomic number and protons, same numbers. So if there's a 29 there, I know that I've got 29 protons. All right, next, I can use the charge to figure out how many electrons there are. I know there's a +2 charge, and that's going to be equal to the protons minus the electrons. So I can do a little math, substitute in to this equation the 29 that I know. So +2 equals 29 minus something. 29 minus 27 will give me a +2. So I know there's 27 electrons. And last, I can get the number of neutrons. And so I know my mass number is protons plus neutrons. Well, that tells me that 63 is equal to 29 plus another number. That's going to be 34. I know that I have 34 neutrons. Sweet sauce. All right, cool beans. That's the end of this video. I hope at this point you feel like you understand what you're looking at when you see a nuclide symbol, what those different numbers and symbols in their specific places mean. And I hope you can use that to help you understand some sweet, 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 sweet chemistry. Anyway, ta-ta. Have a great rest of your life.